Okay, see, in the previous lecture, we are discussing regarding sensor characteristics. So, we have discussed some characteristics of the sensor, like non-linearity characteristics, like saturation characteristics. Again, we have discussed some characteristics of sensor, that is hysteresis. What is meant by calibration? What is the calibration error? Again, accuracy, some full scale output, full scale input, and transfer function. So these characteristics we have discussed in the previous lecture. Today we will discuss about the next one characteristics of the sensor is that repeatability. Okay, so see, we are using word repeatability. It is one of the important characteristics of the sensor. Repeatability, or we can call it as a reproducibility. So this error, it is caused by the inability of the sensor to represent the same value under identical condition. What is repeatability? That means under the ideal condition, the signal obtained from that sensor or the output obtained from the sensor, it is repeated or reproduced, right? Reproduces is nothing but same value again producing. Repeated is nothing but again same value again producing. Okay, so see, repeatability, it is nothing but it is one type of error which is caused by the inability of the sensor, inability of that sensor to represent the same value under identical condition, right? Suppose if we are considering any identical condition, at that identical condition, that sensor or that device, it will use two value, same value, right? Suppose it will give 20-degree temperature at the first condition, same ideal condition it will give again 20 degrees Celsius, right? So it is the repeated value, repeated value. So this repeated value under the ideal condition, it is the repeatability error or repeatability characteristics. See, it is expressed as the maximum difference. See here. So under ideal condition for the two stimuli, or if we are considering one span of stimuli, the value it is obtained, output it is obtained repeated, right? Baga output S1 same ahe, but direction of that it will be changed. Like we have discussed yesterday's hysteresis. Do you know hysteresis curve? Hysteresis curve. So output produced repeatedly, but it is in the opposite direction. So here, if the curve it will be start from zero value, then at that value of stimulus, again this is the output. Suppose S1 is the output at the first stimulus. Again we are increasing some of the stimulus. Then when reverting back, it will give same output, right? So this is nothing but reproduction, or it may be repeatability. This is the one type of error which is caused by the inability of the sensor to represent the same value under identical condition. How it is expressed? It is expressed as the maximum difference between output reading as determined by two calibrating cycle, right? So do you know calibration? Calibration, we are suppose considering one identical or standard, we are comparing the output at that standard. That means suppose weight machine is there, we want to calibrate that machine for 20 kg, that is standard output at ideal condition, but somewhat it will give at this condition. If you are measuring or calibrating that equipment, and somewhat different condition if you are calibrating, there is some difference, right? So this is the one type of error. Same दाखवायला पाहिजे होतं. This is one type of error. So this is the difference between output reading as determined by two calibrating cycle. कॅलिब्रेटिंग सायकल आपण चेंज करतोय, म्हणजे फर्स्ट कंडिशनला कॅलिबर करतोय. At that situation, it will give some output, and the second cycle it will give some output. So there is some difference between that. That is maximum value of difference. What is the maximum value of that difference? It is nothing but repeatability. So it is represented by delta R. It is nothing but repeatability error. It is equals to delta. So delta, it is nothing but it is the span between two input stimuli divided by Fs. What is Fs? Fs, this is the line of input stimuli, this is the line of output stimuli. Sorry, output, not a stimuli. So this Fs is nothing but, we have discussed characteristics, full scale. Full scale input, suppose full scale it is nothing but 10x, and it will give that difference between that is nothing but 2 divided by 10 into 100. So that is the delta R. Delta R, it is nothing but repeatability error. So possible source of repeatability error may be thermal noise. Possible source, how the repeatability error it will be occur, it is due to the thermal noise, as well as a build up charge or material plasticity, right? Material plasticity. So these are the possible source. If this source content it will be present, then it will be gives out a repeatability error or a reproducibility error. So this is one characteristic, that is repeatability. Next one, dead band, right? So dead band, it is one of the characteristics. In that, what is dead band? Some input stimuli, or it may be some input of that sensor, there is an output obtained, it is 0. It is nothing but dead band, right? So that means for that reason, je kai region aseल, for that region the sensor it is insensitive to sense, right? It gives an output 0, that means it is insensitive. Getting? See, a dead band, it is the insensitivity of the sensor in the specific range of input signal, right? See here in this diagram, from this specific range, that means a range from this point to this point, the output obtained from the sensor, it is near about 0. Okay, so this is the output obtained from the sensor for specific reason, or the for specific input stimuli. The output obtained, or the sensor will not give the output or not produce the output signal, that means it is 0. So this is nothing but, this is the dead band characteristics. And output signal, even though if it is sense some input, but it will give 0 output, that means it is insensitive to sense, right? No, त्याला input present आहे, but even though input is present, it cannot give output, or it gives 0 output, that means it is insensitive. So it is the insensitivity of that sensor. Okay, insensitivity of that sensor in the specific range of input stimuli. The output signal obtained from the sensor, it is 0. So this span, it is called as dead band, and this is one of the characteristics of sensor. So in that range, output may remains near a certain value, so often 0 value, right? So over an entire dead band zone. So from that over an entire dead band zone जो आहे त्या झोन मध्ये आउटपुट जे असेल सेन्सरचं, इट इज नियरली इक्वल टू 0 or even it is 0, right? So this is the dead band characteristics. Suppose we are considering sensor gives output in this form, or it is the like as a one graph, or it is one of the transfer function of any sensor. So for that span of input stimuli, the output signal obtained, it is nearly equal to 0. So this is the dead band, or it is the insensitivity of the sensor. Okay, getting? So this is the dead band characteristics. Next one, It is nothing but a resolution. So it is one of the characteristics. Resolution describe the smallest increment of the stimulus that can be sensed. What is resolution? We are defining in case of our camera resolution, right? What is the concept of resolution? Capturing capacity, or in case of sensor, sensing capacity. If there is a small change in the input stimuli, so this is projector, if you are varying that knob, then resolution it will be changed. So that means if the small increment is there or the small decrement is there, smallest increment in that stimuli, it is represented by resolution. All of you understood resolution concept? That means resolution describe the smallest increment of the stimulus that can be sensed when a stimulus continuously varies, right? So for that purpose we are understanding resolution. So if we are having an stimulus, that is stimulus is nothing but input, it is continuously varying quantity, right? Continuously varying quantity. So even though there is a small increment of varying or small increment of varying of that quantity, then it can be also sensed. So this is the capacity of that sensor, whether it will be sensed or not sensed. So this concept is nothing but resolution in case of sensor. Suppose you want to stop your sugar in that bag at exact 50 kg of it, but somewhat smallest increment is there. Suppose 1 gram of increment is there, right? 1 gram of increment is there, then also it can be sensed. So if it is accurate or its resolution is good, then it will stop sugar in that bag at exact 50 kg. Otherwise there is some extra sugar, it will be goes. So this concept related to sensor, it is nothing but resolution of that sensor. Similarly, resolution of our projector, or it may be resolution of camera. So it is depends upon that sensor equipment. When a stimulus it is continuously varies over the range, the output signal of some sensor will not be perfectly smooth, right? See, if the stimulus continuously varying over that range, the output signal of some sensor will not be perfectly smooth even under the no noise condition. Okay, some sensor sense the continuously varying input, it will sense the continuously varying input, but it cannot produce a smooth output, or it not gives the smooth output, perfectly smooth output. Even though noise disturbance it will not project. Okay, suppose resolution of that sensor it is less, or it may be somewhat the resolution error it will be present, and in that point if there is a noise is also present, somewhat that resolution is again reduces. That means त्याची जी काही सेन्सिंग कॅपॅसिटी असेल ती काय होईल, परत रिड्यूस होईल. That means it will cause a more error. लक्ष देते? Yes or no? Resolution, that capacity of that sensor, if the stimulus is varying, so its capacity should be small variation can be sensed. So this is nothing but resolution. Minimum variation असलं तरी पण ते सेन्स केलं पाहिजे. On that factor resolution it is depends. So if you are using sensor for continuously varying quantity, and if your sensor it will not sense that change or varying quantity, then it will not give perfect output, right? It will not give perfect output. So a sensor, it is one of the characteristics. So its resolution should be good. The output may change in the small step. This is typical for a potentiometric transducer, occupancy infrared detector with grid mask. and the other sensor where the output signal change is enabled only upon a certain degree of stimulus variation. See, understand the meaning of that sensor. The output may change in the small step. Suppose there is a variation in the temperature from 20 degree to 25 degree, and sensor it is used to sense that temperature. It will produce output 1 millivolt per 1 degree. Okay, 1 millivolt per 1 degree of change. So if the 5 degree temperature it will be changed, that means it will produce a 5 millivolt voltage extra. So again somewhat their proportion same as that of gear ratio. Proportion पण घेतलेला असेल gear ratio चं. Suppose सेन्स केलेलं इनपुट 100% असेल, at that situation it will produce a output at 50%, right? So small step there is output, it will be changed, and this will be happen typically for potentiometric transducer. Do you know potentiometric transducer? What is potentiometer? Voltage measure. Potentiometric transducer, it will measure the voltage or that varying quantity. So again occupancy infrared detector. So infrared detector or IR detector, it will sense the occupancy. So these are the some sensor having an varying input. त्याचे जे काही input आहे, this is varying input, and the other sensor where the output signal change is enabled only upon a certain degree of stimulus. So some sensor it will provide a resolution in the specific degree of variation. Suppose temperature varying from 25 to 50 degrees Celsius, then its resolution or it will sense that sensor having a good quality. If the resolution or the variation it is beyond that range, right, then we loses our resolution or degree of variation. It will be depends upon that specific range. Suppose in our projector if we are varying that knob beyond that limit, whether resolution it is good, so it's somewhat having a specific range, no? In that specific range their resolution should be good, either less than or more than. Either less than or more than. So after variation there is a resolution, it should be reduces. So this is the concept of, or this is the resolution characteristics of the sensor. Then next one, it is nothing but special properties. So in case of special properties, so some sensor it is needed to specify their special input property. Some of the sensor it is needed to specify its some input property. For the instant, if there is a light detector is there, right? So a light detector, there is a specific property it is required for that sensor. It is nothing but it will detect the light. Okay, so this is specific property of that sensor. If the light ray or incident ray it will follow on that sensor, then it will be sensed. It is one specific property. If the temperature comes in front of that sensor, whether it will be sensed, it is depends upon specific input property, right? So light detector are sensitive within a limited optical bandwidth, right? Again, do you know our eye is one type of sensor? Okay, so do you know color code? Which color is most sensitive or most sensed by our eyes? Why? It depends upon which parameter? Wavelength or bandwidth, no? So angstrom unit, जे काय 4000 to how much? 4000 angstrom unit to not a 6,000. In your electrical utilization illumination subject, there is a graph of that illumination angstrom unit or bandwidth, which material is sensible to that of our eyes. So red color is most sensitive. That means it is depends upon its wavelength or bandwidth. So again, that light sensor, it will be detects that optical bandwidth or ray bandwidth, that is wavelength. Then so that means this wavelength, it is one property, property or quantity of that input stimuli. As per our eye, we clearly visible the red color or more sensitive to red color. That means the bandwidth of that red color, it is nothing but one type of amplitude or one type of property of that red color. Then it is very sensitive to our eyes. Similar to that, if there is a light detector is there, then it is sensitive within a limited optical bandwidth. Therefore it is appropriate to specify them a spectral response. Okay, just 1 minute. Next one property of the sensor is that output impedance. So output impedance, that is impedance of the output side. It is nothing but output impedance or Z out. It is important to know for better interfacing of sensor with the electronic circuit. Right. See, this characteristics, that is output impedance characteristics, it is important to understand or know because we want to interface that circuit to electronic circuitry or that sensor to electronic circuitry, right? So while interfacing, you should know about the impedance of that sensor output, because we want to interface that sensor output with other interfacing circuitry, right, to produce an specific output. So that it is necessary to understand the impedance of that sensor output, that is output impedance of the sensor. Electrically, output impedance, it is connected to the input impedance Z in of the interface circuit, either in parallel, that is voltage connection, or in series current connection, right? See, impedance or do you know resistance, impedance of the sensor output, how it is interface or where it is connected, कुठे कनेक्ट केलेला असतो आउटपुट. Okay, multiplexer or interface circuitry, that means it is connected to interface circuitry. Output of the sensor, it is connected to interface circuitry. So again, output of sensor, it is having and some of the impedance. Input of interface circuitry, it is having and some of the impedance, right? See, suppose this is the sensor output, we want to interface it with interface circuitry, right? This is an interface circuitry, this is an sensor output. So here this sensor output, it is having an some of the impedance, that is Z out. Okay, here it is Z out. There is a electric connection between output of sensor and input of interface circuitry. Electrical connection, and here it is electric connection between output of sensor and input side of interface circuitry. So there is a relation between Z out and input impedance of interface circuit. Okay, so that means suppose it is having an some impedance, it is having an some impedance. Either these two are connected in series. Do you know that it is connected in series, or it is connected in parallel? So that means resistance connection, or it may be impedance connection. Resistance connection, or it may be impedance connection. That is, this Z out, it is interface or it is connected to that of input of the interface circuitry, either in parallel, that is voltage connection, or in series, that is current connection, right? Either in parallel or it may be series. So this is related to output impedance, and we want to understand the output impedance because we want to interface that output of the sensor to the interface circuitry, right? So that here it is one characteristic, that is output impedance characteristics. Then another one characteristics is that output format. Okay, so output format, do you know that sensor, it is a device which can convert non-electric signal into an electric signal, or it will be receives some stimulus and response it into electrical form. So output of that sensor, it is in the form of electrical, right? And do you know that the electrical format, it will include, or the electrical characteristics, it will include either voltage output, either voltage, either current, or charge, or the frequency, or amplitude, right? Phase of that signal, polarity, shape of the signal, time delay, and digital code. So these are the some characteristics of output, right? So that means these are the different types of format of output. Okay, understood? Output format, it is nothing but it is the set of output electrical characteristics, so that are produced by the sensor alone by integrating excitation circuit, or it may be signal conditioning. So the electrical characteristics output obtained from that sensor, it may be voltage, it is one format. No, output obtained from the sensor, it is in the form of current, it is different, another one format. If output obtained from that sensor, it is nothing but it is the frequency, it is different format, right? So that depending upon output format, we want to use the interface circuit, so that we want to understand the output format of that sensor, it is characteristics, right? Output format जर माहित असेल आपल्याला, then आपण interface करणार. If you don't know the output format characteristics of that sensor or the output of that sensor, how we are going to interface? If the output of that sensor signal, it is in the form of digital code, and you are interfacing it with the analog to digital, if you don't know the characteristics, whether it is possible? So that we want to understand the output characteristics or the output format of that sensor, whether it may be voltage, whether it may be current, charge, frequency, then amplitude, phase, polarity, or shape of that signal. Either analog signal is there, shape of that signal in the form of sine wave, shape of that signal in the form of square wave, shape of that signal in the form of triangular wave. So we want to understand, then we want to interface this with interface circuit, right? If you don't know the output of signal in which format, then we are going to interface it? No, right? So we need to understand this characteristic, that is output characteristics, output obtained from that specific sensor in which form. So that this is the output format of sensor. Then excitation. Okay. So do you know excitation? So excitation, why it is needed? Why the excitation it is needed? Already tell, no, in case of active sensor, see excitation, it is the one type of external signal which is needed to enable the operation of active sensor, right? So enable the operation of active sensor, we need to give some external source like current source, voltage source. So this is nothing but excitation. We are providing one extra signal or external signal to enable the operation of that sensor, right? So this is nothing but excitation. So excitation, it is specified as a range of voltage. Okay, so what are the excitation it can be provided? It is in the voltage we are able to provide external voltage, we are able to provide current source, right? External current source, or in some cases it may be a light. Okay, so some cases it may be a light, it is required for excitation. Some cases it is required magnetic field for the excitation. Again, any other type of signal, right? So this is excitation, it is required to enable the operation of signal. So as we have already discussed regarding excitation, so it is voltage source excitation. One example we have given, that is thermistor, no, temperature sensitive resistor. So in that, to enable the operation of that resistor, we required one external source, that is current source, or it may be voltage source. If the current it will start flowing from that resistor, then its operation it will be enabled. Otherwise, not. So this is the active type of sensor, and it will require excitation. Okay. Okay. See, for some sensor, the frequency and shape of excitation of signal and its stability must also be specified. Some of the sensor, there its frequency it is also specified, shape of excitation, which types of excitation it is required, that shape of that signal, its stability. What is mean by stability? Stability. Stability. Stable operation, or it may be system stability. We can call it as a system stability. Suppose you are considering power system. This power system stability, it can be defined when any fault occur, or when any disturbance, or we can call it as a transient occur. What is mean by transient? Transient, it is nothing but again fault, but this transient, it is for small time or less time. Either it will recover itself, right? So this is nothing but transient. If the transient occurs in the power system, whether the system equipment are stable or not, or somewhat it will be damaged. if the transient fault occur. So according to their system stability, it can be determined. म्हणजे एखादा इक्विपमेंट असेल त्याच्यावरती काहीतरी फॉल्ट झाला किंवा काहीतरी इनपुट पॅरामीटर चेंज झालं फॉर मिनिमम टाइम फॉर लेस टाइम, then it is stable or it gives an unstable operation, right? So this is the concept of stability. So here the stability is also represented, and this stability, signal excitation and shape of frequency, it is also specified. So this is we want to understand this one characteristic, that is excitation signal. Next one, some of the environmental factor, it will also affect on the sensor. So see, every sensor, it is subject to various environmental influences during both the non-operational storage and the operational functionality. Okay, see, each and every sensor, while it is in the operating condition, or it may be it is in the non-operating condition, or it may be stored condition, it will affect by some of the environmental condition, or it may be environmental parameter, right? Or it is influences by some environmental influences during operation, or it may be at the time of non-operation, right? So suppose we are considering at the time of operation, there is a effect of heat on that sensor, there is a effect of some natural disaster on that sensor, because sensor, it is always connected or it is exposed with that of environment. So that there is a sensor, it is subjected to various environmental influences during both non-operational condition, that is when it is stored in the specific place, and when its function is going on, or operational condition. All those possible environmental factor that may affect the sensor performance are generally specified by manufacturer. Okay, so manufacturer, after manufacturing, it will specify some environmental factor, it should be effect on that sensor. So suppose if we are considering any sensor and manufacturer represented, or manufacturer mentioned that sensor, there is a, this is a dust proof sensor, dust proof, or if accumulation of dust it will be there, then this sensor, it is inoperative or not sensing. Okay, and if such sensor, if we are using in the industrial area having a dirt or dust accumulation, right? So ultimately its life is also reduces, right, due to dust accumulation, or it may be dirt accumulation. Or if we are considering any paper mill, there is a lot of dust, or it may be dirt, or humid area, some of the sensor is there is a effect on that sensor having and some humidity, other than जर काही effect असेल, if you are using that sensor in that area, so there is a effect on that humidity on that sensor. So that is environmental effect on that sensor, right? No, environmental effect on that sensor, and this is specified by manufacturer. Manufacturer त्याच्यावरती specify केलेलं असेल. So some possible environmental factor that may be affected the sensor performance are generally specified by the manufacturer. So in that, storage condition are the non-operating environmental limit to which a sensor may be subjected during a specified period without permanently altering its performance when operating under normal condition. So when sensor, it is non-operating condition or storage condition, so somewhat limit for there. Okay, how many years or how many days the sensor, it will be stored in the non-operating condition. Do you know any one of the equipment, it is stopped for long time? After long time, if you are taking it for operation, So somewhat its operation it will be not proper. Suppose if we are considering our laptop, it is stopped for long time, long time, or it is somewhat kept in the storage. So after that, after long time, it is inoperative, right? No, so that means it is the effect on the environment on that sensor. There is somewhat effect on the effect on that sensor from environmental parameter, so that it is inoperative. Okay, so it should be subjected after specifying period for the operating condition, or it is should be operating. Do you know, in our DC motor, or it may be any motor, it is exposed in the environment for a long time, and after long time, if we want to run that machine, which test is performed? Firstly, एखादी मोटर जास्त दिवसासाठी स्टॉप कंडिशनला आहे, कोणती टेस्ट परफॉर्म करावी लागते स्टार्टिंगला कनेक्ट करण्याच्या अगोदर? ओपन ओपन दिस इक्विपमेंट मे बी ऑपरेटिव्ह और नॉन ऑपरेटिव्ह, ते ऑपरेट होईल किंवा नाही होईल हा पुढचा प्रश्न आहे. बट विदाउट टेस्टिंग वी कॅनॉट पुट मोटर ऑन सप्लाय कंडिशन, और इट मे बी ऑन द सप्लाय. First of all, we want to conduct one test. ओपन सर्किट टेस्ट करायची, कंडक्ट करायची म्हटलं तर ती लाईनला कनेक्ट करावी लागते. हा, ते चेक करतात. ती कोणती टेस्ट आहे? ते वायर लावून चेक करतात, म्हणजे टेस्ट आहे ना ती. काय चेक करतात? शॉर्ट सर्किट झाला असेल तर पुट करतो का आपण? शॉर्ट सर्किट टेस्ट चेक करतायत ते बरोबर आहे, पण काय चेक करतात? शॉर्ट सर्किट झालंय का नाही. कधी होतं शॉर्ट सर्किट? कधी होतं शॉर्ट सर्किट? हा, इन्सुलेशन. इन्सुलेशन ना, इन्सुलेशन प्रॉपर आहे का नाही चेक करतो आपण. मग कोणती टेस्ट कंडक्ट करतो इन्सुलेशन चेक करण्यासाठी? क्वेश्चन फ्रॉम युअर साइड आहे. बरोबर आन्सर सांगताय तुम्ही, बरोबर आहे, ठीक आहे. शॉर्ट सर्किट टेस्ट म्हणजे शॉर्ट सर्किट झालंय का नाही हे चेक करतो. शॉर्ट सर्किट झालंय का नाही म्हणजेच इन्सुलेशन चेक करतो, वेदर इट इज प्रॉपरली इन्सुलेटेड और नॉट. हाउ द इन्सुलेशन इट कॅन बी चेक्ड, which test it can be performed? What is insulation? Having an how much resistance of insulation? शॉर्ट सर्किट झालंय का नाही चेक करता, म्हणजे वाइंडिंग टर्न आहे, there is insulation between turns to turn, we are checking turns insulation, or maybe face to face fault आहे, or body to winding proper insulation is there, or short circuit झालंय का शॉर्ट सर्किट चेक करा. आता इन्सुलेशन चेक करतो म्हणजे काय चेक करतो? What we are checking? What is the resistance of that insulation? Depending upon इन्सुलेशन चेक करतो. हॅव्हिंग अ हाय रेजिस्टन्स असतो की हाय रेजिस्टन्स असेल तर शॉर्ट सर्किट झालं, की लो रेजिस्टन्स असेल तर शॉर्ट सर्किट झालं. मग आपल्याला काय पाहिजे? शॉर्ट सर्किट नको आहे, रेजिस्टन्स हाय, म्हणजे दोन वाइंडिंगच्या मध्ये रेजिस्टन्स हाय आहे का चेक करतो, किंवा वाइंडिंग टू बॉडी वी आर चेकिंग वेदर रेजिस्टन्स इज हाय. कसा रेजिस्टन्स चेक मेजर करतात? मग वाइंडिंग टू वाइंडिंग असेल, फेज टू फेज असेल किंवा वाइंडिंग टू बॉडी असेल. बॉडी इन्सुलेशन कुठे ब्रेकडाऊन झालंय का, म्हणजेच कंडक्टिंग पार्ट झाला की इट विल शो झिरो रेजिस्टन्स. काय यूज करतो आपण, कोणती टेस्ट घेतो? येस, मेगर. मेगर ना, कॅसेट यूज करतो मेगर. इन्सुलेशन चेक करतो ना. सो any machine, it is stopped for long condition, and if we want to put that machine for operating condition, then we want to check first of all insulation between winding to winding. That means we are conducting Megger test. Without conducting Megger test, we are not directly putting that machine to the light. So like that, some specific time is there within that period, or it may be within that limit. We want to operate that equipment like sensor. Usually storage condition include the highest and lowest storage temperature, right? So we are storing any equipment. Do you know we are storing any one of the tablet, and some tablet required a specific temperature, right? No, आपण फ्रीज मध्ये ठेवतो ना काही टॅबलेट. सो if that equipment it can be kept for a specific temperature, then it is good for some span. Beyond that span, again it will be damaged. So like that, storage condition include highest and lowest storage temperature and maximum relative humidities at this temperature. So again, short and long term stability. So if the drifts are part of the accuracy specification, dirt and drifts, if the dirt or disturbance it will be occur, like transient it will be occur. So there is some short time and long time stability. Okay, then short term stability, it is manifested as a change in the sensor performance within minute. Okay, see what is short term stability? It is nothing but there is a change in sensor performance within a minute, within an hour, or within even a one day. Okay, एका मिनिटानंतर सेन्सर परफॉर्मन्स मध्ये काय चेंज होतोय, स्टेबल राहतोय का नाही ऑपरेट झाल्यानंतर, 1 hour नंतर और 1 day नंतर. somewhat it is related to its age. That means suppose we are considering our incandescent bulb, for long time its age it will be reduces. ऑपरेटिंग कंडिशन नंतर त्याचं एज कमी होतं, बरोबर. सो जे काही लाईफ स्पॅन असेल 400 hours, 300 hours. So like that short time stability, whether that sensor performance it is stable within minutes, within hour, or it may be within a one day. Okay, so this is the short time stability. Short time stability. Long time stability, it is nothing but aging, right? As I have told that age may be related to degrading of the sensor material. So for long time, if it is in operating condition, there is some degradation of that material used for sensor manufacture. Material से काहीतरी degradation होत असेल, due to degradation of that material, it will loses its stability. Okay, or it will not give its stable operation. So which is irreversible change in the material electrical, chemical, mechanical, or thermal properties. So other material also there is a change. Then long term drift is usually unidirectional. Long term drift जे असेल, this drift or long term change जो असेल, this is the unidirectional change. Next one, environmental factor, is that environmental stability. Just within 2 to 3 minutes we will conclude. Environmental stability is a very important requirement. Both the sensor designer and application engineer should consider all the possible external factors that may affect the sensor performance. So sensor designer, or it may be sensor manufacturer, should mention all the environmental possible factor on that sensor performance, or which factor effect on that sensor performance. because customer not know the that characteristics. Customer, those who are purchasing the sensor for particular application, it will not know the characteristics or its whether there is some environmental factor. Customer know only our application or our requirement. So the design engineer or it may be manufacturer should specify there some all possible external effect. For example is given, one piezoelectric accelerometer that may generate a spurious signal if affected by a sudden change in ambient temperature. Okay, see, piezoelectric accelerometer, it will sense the acceleration, right? किंवा आपला काय म्हणतो आपण व्हेइकल मधला ऍक्सेलरोमीटर असेल. So this gives an spurious signal. That means there it will loses its stability if there is a change in temperature or ambient change in temperature. जर टेम्परेचर चेंज झालं त्याचं जे काही आउटपुट सिग्नल असेल तो डिग्रेडेड होईल. ओके, सो इलेक्ट्रोस्टॅटिक डिस्चार्ज, triboelectric effect, vibration of connecting cable, electromagnetic interferences, that is EMI, etc. Again, temperature effect must known and accounted. So again, temperature effect is important. So even though small temperature it will be increases, then its performance it will be degraded. Temperature it will also affect by the dynamic characteristics of the sensor. Again, next one environmental effect is that self-heating error. So somewhat that equipment it will also self-heated. So this is self-heating error. It may be specified when the excitation signal is absorbed by the sensor and changes its temperature by such a degree that it may affect accuracy, right? If that equipment it is self-heated, so its effect is that on the accuracy of the sensor performance or output of the sensor. Okay, so in this way there are two sensor characteristics remaining and 1 point that is units of measurement. So this point we will discuss in the next lecture, and in this way we will conclude in the next lecture this unit. First, only 5 hours unit. We will conclude that unit in the next lecture. Thank you.